Hello, everybody. Today at the Bootcamp Coders, we are going to have a talk about artificial intelligence with a topic of chance of success. Today we have Andrea as the host, as a co-host, which I'm welcoming right now. Hi, Andrea. How are you doing today?
I am doing fine, thank you, Dardo. How about you?
Excellent. I'm doing amazing for today. So let's introduce Abimael, which is going to do the talk today. Abimael, how are you?
Hi, I'm pretty good. Thank you for the invitation and thank you, Andre, for being here too.
Okay, don't mention it, Abimael. So, can you tell us a little bit more about the talk that you are going to do today?
So I've recently been like looking into AI. Like I'm studying web development. Like I'm on a boot camp for full stack web development, but I'm also interested into the topic of AI. And I was researching like libraries for JavaScript because that's the language that I know. So I'm going to give like a I'm going to share a little bit of what I very recently learned.
Okay, amazing. Sounds amazing for today's topic. So, without further ado, I'm going to well leave the stream and Andre too, and the mic is all yours.
Okay,
So,
thank you.
don't mention it.
Okay, let me just share the screen. Can you see my screen now? Okay, perfect. So, like I said, my name is Abimael, and today I'm going to do stock market predictions with machine learning. So first, I'm going to give a little bit of introduction about myself. I have a bachelor degree in entertainment business, and I'm currently, like I previously mentioned, I'm starting full stack web development at a bootcamp. And it's been about 4 or 5 months since I began studying. Before that, I didn't have any experience in coding. But the reason why I decided to learn how to code is because I believe that coding is a tool that can be used in pretty much any industry. For instance, in my case, since I have a little bit of background in entertainment, I'm very interested in the in AI and the what it's doing for entertainment products, such as developing stories with the help of AI, or even making predictions about whether a film or a TV show or a video game will be successful or not. So in this presentation, I'm going to share just a little bit of what I very recently learned about machine learning. And I'm going to use this library called Brain.js. Even though Python is usually the language that is mainly used in machine learning, but since I'm studying web development and I know JavaScript, I wanted a library that can adapt to JavaScript. And Brain.js is actually very simple to use, and I think that it's a very good introduction for someone who is already familiar with JavaScript. So let's get into it. So as you can see here, I have in my dependencies, I already installed Brain.js. I run npm install to install this dependency, but you can also use a CDN link if you want to. So before I get into stock market predictions, I want to do a very simple exercise in order to get familiar with the concepts that we are going to see. So here I'm requiring the brain.js dependency, and I'm assigning it to a variable called a brain. So let's begin by talking about what brain is. So brain, well, obviously we're talking about an artificial brain, and as in any technology or most technologies, what we're trying to do is to recreate a human functionality. So in this particular case, we are trying to recreate the human brain, so to speak. And in machine learning, that's called a neural network. And a neural network or an artificial brain is just like the human brain. It receives inputs to produce some outputs. So it gets some information, learns from that information, and then does something with that information. In our exercise, we want a neural network that will be able to make predictions. So we as humans, we make predictions all the time. So for instance, it could be something as simple as if I say something like 1, 2, 3, 4, and then I stop. Your brain will probably make the prediction that my next step will be 5. Like by the time I say 4, your brain was already making that prediction that my next step will be 5. And the reason for that is because we learn by repetition. When a pattern becomes recurrent, and we are more likely to be able to predict the following step. And in this case, since we've already heard a lot of people counting, and usually 5 is followed by, I mean, 4 is followed by 5, then it's very easy to make that sort of prediction. And that's kind of like what this simple exercise it's trying to represent. So the first thing that we need to do is to create our neural network. So we do new brain that recurrent in this class called LSTM time step, which stands for long short-term memory time step. And what this net is going to be able to do is to receive some information and then go over that information repeatedly or recurrently until it's able to learn it. And we call that process training. So in order to train, we do net.train, and we send some data. In this case, we're just sending an array of 1, 2, 3, 4, 5. And if you notice, this is an array that's inside of another array. If I send something like this, it's not going to work because LSTM time step is expecting an array of arrays. And I also have this optional parameter, which is an object with this property log. I set that to true in order to be able, so we can be able to see how the net is training, as you are going to see right now. So this is what we get when we use this property, which is optional. But I wanted to explain you what this is. Basically, iterations, they represent the number of times that the net went over the data, or in this case, the amount of times that the net counted to 5 in this particular case. And as you can see, the least iterations we do, the bigger this training error gets. As you can see right here, the training error is too big. And training error is pretty much like the likelihood that the net is going to make a mistake when counting to 5. And as it iterates more and more, that training error begins to get lower and lower until you can see this as practicing, like the net is practicing. And then it reaches a very low amount, and then that's when the net feels that it's ready to run and make predictions. This will never be 0, because there is always going to be a chance of that the net is going to be a mistake. So it will never be 0, but it has to be something very, very low, like 0.00 something. So once we train, we can run our neural net. So we do net.run, and we send something like 1, 2, 3, 4. Here, what we're asking is basically what's the number that is followed by 4. And so if we run this, we should get something close to 5, as you are going to see right now. So we train, and after like 5,000 iterations with this training error, we get this number, which is 4.99. Like I said, something very close to 5. It's never going to be exactly 5. It's always going to be something very close, but around that number, like 4.99 something or 5.00 something. The reason for this is that, or at least the way that I interpret it, is that the net is never 100% or 1000% sure that 4 is followed by 5. But as long as you get something around that amount, then we're good. So now that's pretty much the basics of it. We create our brain, then we train it with some data, and then we run it. So now let's jump into stock market predictions. So I have this JSON file, which is an array of 20 elements, 20 objects. Each object represents a day in the Netflix stock market. These are the prices for one of the days in the Netflix stock market. In this particular case, we have all of these properties, but we only care about four for this exercise, which are O, C, H, and L, and they stand for open, close, high, and low, and these refer to the stock prices. And something important to notice is that the difference between this exercise that we are going to do and the previous one is that the numbers that we are going to be dealing with in this case are more complex. They are way bigger and complex. And because of that, our neural net is going to have a hard time or it will take a long time to make sense of these numbers and produce results with these numbers. So what we are going to do is um, we're going to translate these numbers into zeros and ones, because that's the way that the neural nets are instantiated. So it's kind of like the language that they speak, zeros and ones. So the main idea is that the bigger number in this data, the biggest stock price, which by the way is this one, $402, is going to be translated to one, and the lowest one is going to be zero, and everything in between is going to be translated to something in between zero and one, so like 0 point something. And this sort of like translation, it's called normalization, which means that we are normalizing, or we are making the data normal for a machine to understand. So once we require brain.js and our raw data from our JSON file, I have this function called normalize. And this function receives a step, and a step is 1 day in the Netflix stock market prices. So this is a step, this is another step. And this function is going to return an object with only the properties that we care, which are open, close, high, and low. And we want to normalize each one of those properties, meaning translating them into zeros and ones. And for that, we have a very basic math formula, which is right here. And pretty much is the current value, or the result of the subtraction of the current value minus the lowest value. That result divided by the highest value minus the lowest value. In this refers to the highest and lowest in the entire data. And that division is going to return the normalized value. So as you can see, we are applying that formula in each one of the properties. And so you can see how this looks. I'm going to console log one step in our raw data. In this case, it's the first one, and we're going to normalize it. So the first one is this one right here, which is the one that, as I previously mentioned, has the highest value in the entire data. So now I'm going to run node stocks. And as you can see, this is what this function returns, which is an object with the normalized values of each one of the properties. So as you can see, high is number one, because that's the highest number in our entire data. So in order for you to compare it to the element that has the lowest value, which is the one with index 15, like I mentioned previously, this is an array of 20 elements. So the last one is index 19, 18, 17, 16, and 15. And the lowest value here is 329. This is the lowest value in the entire data. This is something that I checked before I began the presentation. So if I normalize this day, I should get 0 on low, as you should see right now. As you can see, we got 0 on low, meaning that this is the lowest value. And the previous one, the first one, has the highest one. And everything else is going to be something in between 0 and 1, like all of these properties. So this is the way that we're going to build our training data. This is how the net is going to receive the information. But that's not how we want our results. We don't want to see zeros and ones. We want to see something that we can understand. We want to see some stock prices. So at one point, we will have to do the opposite of normalizing, which is denormalizing. So I have this other function called denormalize. And this function receives an already normalized step. So for instance, something like this, it receives something like this and then denormalize it, meaning it brings it back to what it previously was, to its original value. And as you might guess, in order to do that, you simply perform an inversion of the previous formula. So in this case, we already have the normalized value that resulted from here, and then we kind of just like we go backwards. So instead of dividing, we are multiplying, and then instead of subtracting the lowest value at the end, we are adding. So it's a pretty basic inversion of the previous formula, and that will give us the denormalized value. And again, we apply that formula to each one of the properties. So now let me comment this one out and just make the comparison of a normalized step and a denormalized step. As you can see here, we are denormalizing the result of a value that of a element that we are normalizing. So we're denormalizing an already normalized value. And so I'm gonna run it again so you can see the difference. As you can see right here, this one is a normalized step and this one is a denormalized step. They are the same. I mean, they are equivalent. The difference is that this is something that a machine can understand, and this is something that we can understand. You can see, the lowest value is 0, and which is 329, as I previously mentioned. So this is just one day in the Netflix stock market prices, but we want to be able to train all of the data, in this case, all of the 20 days. So I have this constant called normalized that data, and I'm mapping through the entire raw data, and I'm normalizing each one of the objects. And as I mentioned here, LSTM time steps receives an array of arrays, but map only returns one array. So what we can do is to slice the data. Since it's like 20 elements, we can do like 4 smaller arrays of 5, as you can see right here. And then if I console log the training data, let me just comment this one. You should see 1, 2, 3, 4, 5. That's one array, and we should have 4 of those. So that's our training data. Now that we have our training data, we can finally run it. So let me uncomment this. Again, we do new brain recurrent LSTM time step, and then we send our training data, and I'm going to log the results on the process of the training process. I think I have a typo here. Let me check. Oh. Sorry about that. So now let's do node stocks. It's training, and as you can see, this here what we pretty much asked is we are running the net, and we are sending the first element of our training data. In this case, we're not sending a single day, but 5 days, because remember we sliced our data into smaller arrays of 5. So what we are asking is after the first 5 days, so after these 1, 2, 3, 4, 5, what are going to be the results, the stock prices of Netflix on the 6th day? And this is the result. And as you can see, this is the normalized version of the results. This is something that we cannot easily understand. So we are missing something, which is our denormalized function. Denormalized. So now if we run it again, we should see the difference. Oops, I think I made a typo. Let me just copy and paste. Now it trains, and this is something that we can more easily understand. Now, if we make a comparison of, let me just double check, 1, 2, 3, 4, 5 of the results that actually happened on the sixth day compared to our predictions. We have that it opened at 387, and our prediction was 396, then 394, and 368, 397, 389, and 382, and 368. So it's like in the previous example where we didn't get exactly five, is the same in this time, but the difference is that we are now dealing with bigger amounts. And but as long as we get something again close to the actual, um, what actually happened, then that means that our net is doing what it's supposed to be doing given the information that we provided to it. And I'll talk about that a little bit more later. But first, I want to also show you something else that we can also do. Instead of running the net, we can also use forecast. And in this occasion, instead of just sending one step, we're going to send, instead of sending the first 5 days, we're just sending a single day. So it's the first element, which has 5 days, and then the first element of that first array. So we are talking about the very first day. And what we are asking here is what is the forecast of the following 5 days, which are represented in here in this parameter. And we can do 3 or 10 or as much as we want. In this case, we're just going to do 5. And since forecast, instead of returning a single object like run, is going to return an array of 5 objects or 5 days. Because of that, we need to make sure that we map through all of those elements and denormalize each one of them so we can get a result that we can understand. As you can see right here, we got five results. So if we compare again, this is what we sent, and then we got the forecast of 1, 2, 3, 4, 5. And if we compare the last one, the last one that happened in real life with our predictions, we get 387, 391, 394, 380, 397, 389. Again, something around the actual amounts. Now, it's important to understand, to keep in mind that everything, all the results that we might get here are going to be very, very simple, because all that we're doing is to identifying some patterns or some tendencies in only 20 days of worth of Netflix stock prices data. If we had a way bigger data, or like a longer range of data that we cover, then our predictions will be more accurate, or even better if we also had also information from companies that are similar to Netflix, such as HBO, Disney, or Hulu, or something like that, then it's going to be even better. However, one of the main points that I would like to make in this presentation is that even if we had all of that, like a very big data with information from multiple companies, that will still that wouldn't be enough, because like I said, all we're doing is identifying some patterns, and also assuming that whatever conditions were in place when we got those results are going to stay the same. So I'm trying to bring this back to what I said at the beginning of the presentation about how coding, or in this particular case, machine learning, can be used as a tool in any industry. And having knowledge in your particular industry can help you a lot. Like, for instance, since I have a little bit of background in entertainment, I could use some of the materials that I have in order to make better predictions, because in the neural net that we built, this neural net, like I said, is very simple and doesn't know, for instance, it doesn't know the business practices that Netflix is implementing that might drive the stock prices up or down. It doesn't know what is the Netflix catalog, which are the products that they provide. What will happen if they remove a movie or a TV show from their catalog, or what will happen if they add a new one? It doesn't know none of that. So I think this quote that I have here from an entertainment science book kind of like summarize what I'm trying to say, which is that in the era of almost unlimited data and computer power, the combination of smart analytics and powerful theories can provide valuable insight to those who have room for them in their decision making. So the keywords here are smart analytics, and not only smart analytics, but also powerful theories, meaning not just relying on patterns or tendencies, but also developing theories that explain or that explain what are the causes of those patterns, and finding a way to somehow implement those theories into our code in order to get better results. And yeah, that will be it for my presentation. Thank you.
Thank you, Abimael. We are back, and Mariana Romero just joined us, so I'm going to add her to the stream. Hi, Mariana. How you doing? I think that she might be away from keyboard. But going back to your presentation, Abimael, it was a great presentation. So I'm not sure if the people who is watching us has any question. Remember that you can add the comments and we can show your question here. But I actually have one question, Abimael. How do you or how do you think this is approachable from a developer? So is this something really complex, or is this something that you can easily access? Because I saw that you have the Brain.js framework. I guess it's a library, but is
Library.
it really hard to use? Is it really complex? How approachable is that library?
No, actually, that library is pretty simple. That's what I mentioned at first, that it's a good introduction. It's not going to tell you all of it has a lot of limitations because, like previously, I wanted to do an exercise that was going to be even more complex. And since the only experience that I have is in web development, I as I was like researching about it, I realized that I will have to acquire a lot of knowledge in order to do exactly what I wanted to do. But I found that Brain.js, which it doesn't include, uh, it saves you all of the math that goes on in artificial intelligence, which is something that I didn't know, that actually it's very math heavy, and that's like one of the main advantages of that particular library, is that you don't have to do much math. And if you're already familiar with JavaScript, it's a good introduction. Like you shouldn't stop there. Obviously, you should, like, I guess the best idea is to learn Python or R. But as someone who only knows JavaScript, that's a great introduction.
Okay, amazing. Also, well, mm, we saw your counter and the stocks example, but how would you apply, taking into account that you have experience with entertainments? Well, you have the entertainment media or all
Mhm.
these uh, related things. How will you apply that to that area?
So, for instance, I could try to, instead of predict stock prices, I could predict the box office of a film, which is what I was trying to do previously. But it got really complicated because I needed to also include way more variables in order to make it more accurate. So, for instance, I could have use some of the introduce, like I said at the end of the presentation, introduce theories about what are the success drivers of entertainment products into the data. Like what is data telling us about what makes a movie successful, and finding a way to implement that into the data, and not relying only on patterns, which is what I just did. uh, my next step for me in this AI journey will be that to find a way of how to implement more variables, to take into account what happens if it's a Monday, which is the day of the week that people people don't go to see movies as much on Mondays. And what will happen if it's Monday? How can I make my neural net to take that into consideration, and many other stuff. The more data you have, combined with good theories, the better.
Okay, yeah, because I guess that will mark that will be really interesting for media theaters to know that when to display some movies or how things work like that, right? To get more information about this, even the Netflix, Disney Plus, or media providers, and when to launch a new movie or the date or a specific time. So it sounds really interesting, and it's really something that I guess that you could recommend for anyone that it's in the development area.
Also, the recommender algorithms that Netflix have, like when they, they get your data of what are the shows and movies that you're watching, and with that they develop a machine learning algorithm in order to give you better recommendations.
Yeah, I also read about the Netflix algorithm that changes the picture of the movies or the TV shows in based on different your profile. So
Yeah.
if you have even in your own house, maybe you have your wife and your wife has a different profile. So the movie, the TV show, The Office has a different poster image than
Mhm.
your account. So
Oh
I
yeah.
guess that's the machine learning working based on how. I think that it's about how it's more probable for you to watch that movie or TV
Yes,
show.
it's all about probability. That's, I guess, that's the difference between machine learning and just coding in general. Is that coding is a little bit more precise, and machine learning is more like probable.
Ambiguous.
Yeah, you never get like an exact result.
Yeah. Well, amazing. Andre, Mariana, anybody has any comment, question for Abimael?
First of all, congratulations, Abimael. It was really interesting and really thorough, your presentation. I just wanted to ask you, have you ever like tried to resolve or make a prediction on, on real life with
No,
machine learning?
I literally just started like 2 weeks ago with this, because like I don't have any experience in coding. Like previously, before starting the bootcamp that I'm currently in, I had zero experience. So the past 4 or 5 months, it's all been just web development. And but I before I began the bootcamp, I was actually deciding whether to do a bootcamp on web development or AI. So that's always been a topic that I'm interested in. So I wanted to just have a little bit of overview, or like an introduction, yeah, into AI by using what I already know, which is JavaScript. And but yeah, in the future, I'm definitely gonna start doing predictions in the stuff that I'm interested in. That's definitely in my plans.
Oh, that I know that Andre was going to ask which stock do I need to invest right now. Abimael, give me the names.
Yeah.
Yes, give me the list.
Yeah, but like I said, it's not just identifying patterns. This is what a lot of people usually just do. They just identify patterns, but there's a lot of variables. There's a lot of like business decisions that people do, and that drives the that affects the stock prices. So that's what I said, that it's okay to have these skills, but it would be even better if you also have a little bit of theory in a particular area, or teaming up with someone who is already an expert in that, and in order to get like better results and not just relying on technology.
Okay.
Although I don't know, maybe in the future, maybe technology will be able to do that as well. Who knows?
Uh, I got one more thing, Abimael. You mentioned that you have just started the boot camp, well, the full stack boot camp, and you are just getting into these predictions and things like that, starting 2 weeks ago. As a well, I guess that will make you a junior developer. So, as a junior developer, what advice do you have for new developers that are starting to learn full stack technologies, or maybe also machine learning or AI? What advice do you have for them, seeing as you are starting to?
To enroll into a boot camp. or to follow any program, to follow a program, not just trying to. I don't think it's a good idea to just try to learn by yourself, by just like watching like tutorial. Like you can learn a little bit, but it's better to have like a rigorous um, plan that has some deadlines in order to boost you to advance more quickly, because like for instance, I feel like, because, and that's just because this is just me, but I feel that if I wasn't in a boot camp, I would probably, after 4 months, I would still be on CSS, like trying to become like a god of CSS, like try to learn everything that I can about CSS. And but a boot camp or any program who has like a structure, they know when you are ready to take the next step, and so you don't fall into that trap that you think that you still have a lot to learn about a particular technology in order to jump into the next topic. So I feel like if you don't have a plan, it might take you can still do it, but it will take you way longer because you don't know where the limitations are, or where when you are ready.
Okay. Yeah,
So
sounds yeah, it sounds like a great advice. And to also follow well, to keep practicing, right? Because
oh yeah, of
if
course.
you leave the things out, it's not going to help. Andre, any other question? Mariana had a trouble with her laptop, so she got to leave. But Andre, do you have any other question, comment, something for Abimael?
I just wanted to comment on that last thing Abimael said, that it's really true. Before I entered the boot camp, I well, was checking a tutorial on Udemy, and I watched a lot of videos. And for example, I went through a lot of JavaScript, but really I didn't learn much of that. Like Abimael said, I spent like 4 or 6 months like only learning HTML and CSS, so it gave me a good expertise on that, but I think I wasted a lot of time on I don't know, on going too deep on basic concepts.
Yeah,
Mhm.
Yeah. So there you go. Another experience of learning, well, web technologies or full stack technologies. So, well, I think that that's everything. Today, the public has been a little quiet today, but don't worry. We can, on maybe on the next session, we might have Abimael as a
of course.
co-host if he agrees. And but I think that will be everything for today. Abimael, any last words that you have for today's for your topic or for
Well,
anything about maybe your network, your social networks, if someone wants to reach you, LinkedIn, Twitter.
yeah, you can find me on LinkedIn on Abimael-Monarrez. I also have a Medium account, which is at Abimael.monarrez58. Adam, it's been a while since I've wrote something there, and I don't have anything related to technology yet, but that's something that I'm going to do in the future, to start writing about technology. And besides that, well, just thank you again for the invitation, and thank you, Andre, for being here. And I will encourage anybody who's starting to learn how to code, and who's watching, to participate in this type of activities, because it's a really good exercise. It's just it's a great opportunity to learn even more, um, because you can, that one of the best ways of learning is by teaching. So it's kind of like the information or the knowledge has to like come into you, and then go outside, like flew through you. Feel like that's like the best way of learning. Teaching is the best way of learning.
Yeah, I agree on that. You need to understand first to know how to do something, then you need to relearn something to be able to teach someone or to explain that concept.
Yeah,
So you learn twice.
exactly.
Okay. Thank you again, Abimael, for your time, for this amazing presentation. Hope this is not the last time that we have you here with us. And thank you to Andre for being here. Also, thanks for Mariana. Sadly, she got to leave earlier, but we hope to see you again really soon. And watch our channels to know when it's going to be the next presentation. Take care.
Thank you. Take care.
Bye.
Bye.